What if I told you that you had an army running through your veins? This sounds maybe unrealistically epic, but it also happens to be true in a sense. So, say you're biking along and you fall. Not that it happens to me. Well, okay, maybe it does, but you fall and you scratch your knee. Now, this can be a problem because it can provide a potential entry point for dangerous pathogens like bacteria or fungi or viruses. Luckily, we've been evolved to be able to handle this situation in a lot of cases. You'll have cells that send out the stress signals to your body, and they call in this army that I was mentioning at the beginning. Now, the foot soldiers of this army are cells we call neutrophils, and those are the ones I focus on. They're really good at flooding in and chasing after and destroying these enemy pathogens. They do this by grabbing onto the pathogens and actually eating them and dumping toxic chemicals on them. This is a remarkable process, and it's really close to home. It's really right at our fingertips. I mean, literally, if I were to prick my finger and look at the drop of blood under the microscope, I should find over 100,000 of these cells ready to go. I've been fascinated by these experiments that I do from from the start. I mean, if you see these images, they're remarkable. What we do is we hold these cells in glass micropipettes, which are these tiny little glass straws. We also use these to hold a pathogenic particle. We watch the cell respond to the particle and eventually eat it. And this will happen in a matter of minutes. And you just look at this and you start to wonder, how in the world could the cell accomplish this? I mean, just imagine for a second that you are tasked with building a machine this small, capable of these tasks. Uh, they're really small. I mean, this bar here is 1/10 of the width of a strand of hair. So if we scale everything, strand of hair would be the width of this entire slide. So, but nature has managed to design these machines. Okay, and when we think of machines, we also think of having controls like on and off switches or dials. And this is true for cells as well. And these signals, these controls, are often chemical in nature. I'm focused on particularly one of these chemical signals, which is calcium concentration inside the cell. And that's what you see in these green images. When the cell is brighter, there's a higher calcium concentration. And what you'll notice in this one sequence is that when the cell starts eating, we see a much higher calcium concentration. And so you could possibly think of the calcium as maybe a sort of on switch or a dial telling the cell to get a move on and speed up and consume this pathogen. Now, we don't know exactly what the calcium triggers within the cell and why this is important for the process of the cell eating. So if we're able to answer fundamental questions like this, we could solve problems when things go wrong in the immune system, or maybe we could even tell immune cells to not only attack pathogens, but also things like cancerous cells. So the options are really endless, and I'm excited to see where this can take us.